Let's talk about a major problem that's happening right now, mostly out of sight, at the bottom of our rivers. It's a silent threat to our water and energy security, and it's called reservoir sedimentation. To get a sense of the scale here, 5 to 8 billion euros. That's the estimated cost every single year just to clear out unwanted sediment from reservoirs in the European Union alone. We're spending billions on what's essentially just misplaced dirt. And this is absolutely a global issue. Projections for 2050 are quite startling. Reservoirs across North America and Europe could lose nearly a third of their ability to hold water. And for a country like Japan, that number jumps to a staggering 50%. This loss directly threatens everything from our drinking water supplies to our ability to generate hydropower. Now, what's making all of this worse is climate change. We're seeing more extreme weather, right? Heavier rains and more powerful floods are washing huge amounts of sediment into our river systems. This chokes our reservoirs, reducing their capacity. Then, when a drought hits, we have even less water stored away when we need it the most. So, what have we been doing about this growing problem? Well, that brings us to the current methods, which, as we'll see, involve some very problematic trade-offs. To really understand the challenge, consider this finding from Taiwan. A single major storm can dump 2 decades worth of sediment into a reservoir all at once. How do you even begin to manage that? The traditional methods just weren't designed to handle shocks to the system on this scale. If we look at the traditional toolkit, we find things like check dams, which try to trap sediment, or flushing, which uses massive amounts of water to wash it out, and dredging, which is basically scooping it out with heavy machinery. But each of these has serious downsides. They consume a lot of energy, they can damage river ecosystems, and they often waste the very water we're trying to save. And that leads to this fundamental dilemma. The solutions we've been using are creating a whole new list of problems. They harm fish and other aquatic life, they pollute, and structures like check dams can even fail during major floods. Plus, they're just temporary fixes that have to be repeated over and over at great expense. This is clearly not a sustainable path. What's needed is a complete shift in our thinking. Instead of fighting a constant battle against the river, a new approach suggests we can manage sediment much more effectively by working with the river's own natural power. At the heart of this new approach is something called open-flow fluid dynamic technology. The idea is remarkably elegant. It uses the water's own swirling motion, a vortex, to separate heavier things, like sand and silt, from the lighter water. And it accomplishes this without any moving parts, which is key, because it means the system doesn't get blocked. And the best part? It doesn't require huge amounts of external energy. The system is designed to harness the river's own natural current as its main power source. This makes it a truly self-sustaining and sustainable solution. So let's look at how this principle is built into a complete integrated solution. It's called the run-of-river sedimentation management system. The name itself, run-of-river, tells you a lot about its philosophy. It's designed to work with the water as it flows, not by stopping it. The process itself is quite simple. River water flows into the system. Inside, the design generates a vortex. The spinning motion creates a centrifugal force that pushes the heavier sediment out through a separate channel, while the cleaner water continues on its way back to the river. And because of its non-blockage design, it can run continuously, even during floods when sediment loads are highest. When you put this new system side by side with the old methods, the contrast is clear. Where dredging uses massive amounts of energy, this system is energy efficient. Where check dams can harm ecosystems, this is designed to be ecologically friendly. And where flushing wastes precious water, this system preserves it. It addresses each of the major flaws of the traditional approach. This isn't just a clever piece of hardware. It's a smart, 21st-century infrastructure solution. It's equipped with IoT sensors for constant, real-time monitoring. It uses big data and AI to analyze patterns and predict sediment flows. And it employs a digital twin for simulations and planning. So what does a digital twin actually bring to the table? It's a perfect virtual copy of the real-world system. This allows engineers to test and perfect designs in a simulated environment before ever breaking ground. Once it's running, it uses live data to optimize the system's performance. It can also predict when a part might need maintenance long before it ever fails. While this technology was designed to solve a specific problem, its potential impact is broader. Let's zoom out and look at how it can help secure the future of our water systems as a whole. Keeping reservoirs free of sediment creates a cascade of positive effects. It ensures hydropower dams can run efficiently, supporting renewable energy. It improves water quality, which lowers treatment costs down the line. It reduces flood risk by preventing riverbeds from building up. The captured sediment can even be reused, perhaps in construction, which supports a circular economy. It's a win all around.
And all of this circles back to the core mission behind this technology. The stated goal is simple but powerful: to ensure water security for both livelihood and sustainability. It's about finding a balance where both people and nature can thrive.
This system offers a powerful example of what can be achieved when we choose to innovate with nature's own processes.